Hi everyone. Today let's solve Pytorch implementation called mean intersection over union. So this question is very popular in many coding interviews for computer vision and engineers or machine learning engineers. Actually, I have interviewed two companies for computer vision, and they both asked me this question. So I think it's very crucial for us to be proficient with the coding part for mIOU. Now, before writing code, let's think about what mIOU is. So mIOU is a quality matrix in object detection. It measures the goodness of object detection algorithm. The mIOU specifically will measure the difference between the predicted bounding box and the ground truth bounding box. If that difference is small, this means the intersection over union score is high and the object detection result is good. Usually, we have 0.5 to indicate a fair object detection, and we have 0.7 to indicate a good object detection. And if the mIOU is greater than 0.9, this means the object detection is excellent. Okay, now finish the brief concept for mIOU. Let me use a drawing here to help you understand how to solve this kind of problem. Okay. So the first thing we have to consider is that we have the predicted bounding box, right? Let's say the red one to represent the predicted bounding box, and I'll draw here. And then we have the blue one, which I will use then to predict represents the ground truth bounding box. Okay. After this, we check the coordinates for this predicted bounding box and this ground truth bounding box. So you see x1 and x1 is the left boundary for this predicted bounding box. And then x2 is the right boundary for the predicted bounding box. Now y1 is the lower boundary and y2 is the upper boundary. So for example, here, we can use a drawing here. x1, y1 refers to this point, and x2, y2 refers to this point, and same for the blue one. So I draw here, this point is x1, y1, and this point is x2, y2. Okay, now you can sense or what the coordinate represents. The next thing is to solve the coordinates for the intersection area, which I'll use this yellow one to represent. So to calculate the area for intersection, we have to get the four coordinates or intersection area. So as the same, we want to get the x1, y1, and x2, y2. So how to get the x1 for this intersection area? Well, we see the left boundary of this intersection area is actually this line, right? And this line is the maximum between this x1 and this x1. So I'll write it here. We'll get the maximum between the red x1 and the blue x1. Okay. And we have the blue x1. And how about x2? Well, we see the x2 is the right boundary of this intersection area. So it's a minimum between this x2 and this x2, right? Let me write x2 here. So x2 is the minimum between the red x2 and the blue x2. And do the same thing for y1, we want 2. We will write y1 and y2 here. Y1 was maximum, and y2 will be the minimum. And the only thing we passed is, sorry, here's a typo here. So the only thing we pass to y1 is the red y1 and the blue y1. For y2, only need the red y2 and the blue y2. Okay. Now we get a sense of how to get the coordinates of intersection. Well, the next step is calculate the union because we are calculating the intersection over union, right? So before calculating union, let's think this out and think about the formula for union. Well, actually, in mathematics, to calculate the union, we have to get the two areas and deduct them by intersection. So the first area we see is for the predicted bounding box. So this area is for the predicted bounding box. You see it's included in the section, right? And we also need area for the ground truth bounding box. And you see, okay, this area is for the ground truth bounding box. And union is actually, let me write it out here. Union is the predicted area. So predicted and the ground truth area. So plus ground truth and deduct this intersection. Okay. So deduct the intersection and we'll get union. Once we get the intersection and the union, we just need to use this formula. So LU is the intersection over union. So it's intersection deducted by union. Okay, sorry for my pro joining here. And once we get the RLU, we just calculate the mean LU and we get this mean intersection over union. Okay, I think the drawing will make some sense. Now let's dive into the coding part. So the first thing we have to consider is to get the coordinates from this array, right? So we have to get the coordinates from for the predicted and ground truth bounding box. And after that, we want to get the coordinates for the intersection, as I explained before. Now we get both coordinates, we can actually calculate the area for intersection. And once calculate the intersection area, the next thing to calculate is the predicted area and the ground truth area, right? And once we get the predicted area, the ground truth area and intersection, we calculate the union. And once we get the intersection and union, we can calculate the IOU or intersection of union. And finally, we have the IOU, we can calculate the mean IOU and return the mean IOU to finish. Okay, now feature coding comments. Let's write the code itself. So predict S1 is just passed in this array here. Since we don't know how many bounding boxes we have, in here we use this expression in Python. So we include all the elements from all bounding boxes. And since we're counting the first element here, we use index 0 because it how Python works. And predict S2. Okay, we just copy paste here and change this to 1, so I'm getting the second element. And predicted y1, that copy here to change this to 2, so I'm getting this y1. And finally, we get our y2 on the predicted bounding box. Okay. So, okay, now finish predicted bounding box. Let's think about the ground truth bounding box. So ground truth bounding box, we just work the same. So for ground truth x1, we just copy paste here. Okay, so here, the ground truth, so starting at here, and the ground truth x2 will be changed to 1, and then ground truth y1, and we also need the ground truth y2. Okay, so let's copy paste this element. Change here to 2, change here to 3. Okay, now get the coordinates for predicted and ground truth less so the coordinates for intersection. As mentioned before, the intersection, let's say the intersection has x1 is the maximum between this x1 and this x1. So change it here, and x2 is between the minimum of this x2 and this x2. Now same for the y1 and y2. So copy paste here, save some time. The y1 is here, y2 is here. We change it here to y1, and change here to y2. Okay, now picture that let's solve the intersection. Well, we know the intersection is just the rectangular area, so it will be x2 minus x1 multiply y2 minus y1. But here we don't want any negative element to appear in the intersection, so we use this clump 0 function in Python to avoid any negative elements, right? And once again, intersection next things calculate the predicted area and the ground truth area. You know, the predicted area is just the rectangular area for predicted bounding box. So let me use it here and use a bracket, and then the predicted y2 and predicted y1. So copy paste here, change it here, and write it here. And same for the ground truth. So just copy paste here and make slight change. Okay, now get predicted area, choose area. One thing to consider is that this value might not be the positive one, so we have to add the absolute value for both one. The next thing to calculate the union, right? So union is this predicted area and this choose area and deducted by the intersection. Okay, now finish the union. Next thing to calculate IOU. So IOU is intersection of union. So intersection divided by union will get this one. And finally we'll get the mIOU, which is the average value in Pytorch array. So we use domain function pass its IOU, we get the mIOU. Finally return the mIOU. Now let's quickly check if I make mistakes or typos in this coding part. Okay, so this part good. This part no mistake. This part is good. Oh, sorry. Here we have to use torch, max torch to min, so we can handle the multi-array scenarios. And this part good, I think. Okay, now finally, let's run the test cases to see the mIOU or whether it's 0.75. Okay, you see the test case pass, the mIOU is 0.75. This means our coding part is correct. And by the way, this object detection result is not bad. It's greater than 0.7, right? Okay, I hope you will find this video helpful, and I'll see you next time. Thank you.